Error in division or quotient is what we are going to see as our last propagation, the fourth here. Now, we say what we define or is define what you are going to use in your process. So we say let x and y be approximated. If they are approximated, it means that the exact values to x and y with errors dx and ey respectively. Remember that error is exact minus approximate. Our exact is that to x minus the approximate will be equal to x. And if the exact division will be the exact over this, then approximate will be this over this. And since x and ey are small, they are errors, then their product will approximate a 0, then the spread of 1 will approximate a 0, and the other one. And if you get something small and divided with something big, you get something almost approximating a 0. You get 0.005 divided by 650. You see something you get is approximating a 0. Okay, so now our error in a quotient, our error in x over y, it will be now the exact, which is x over y, then minus the approximate, which is x over y. Now from there, what happens is we remove this and we introduce it, we remove these capitals. So from here, you can see that my x capital is going to be x plus ex. Then here, my capital Y will be y plus dy, if I make them subject. Okay, so what happens, this one now we are going to be having our x is going to be now x plus ex over. Now from there, what is going to happen is cross multiplying. So if I cross multiply, this will be having now, here will be having yx plus yex, then this times this will be having, then minus xey, the whole thing over. When I multiply this and this, I have y squared plus yey. So now this cancels with that. And so what we are having that is surviving is this and this, which I can say this is the same as yex, okay, plus and negative xey. Now all over, you see, if I factorize out y squared, because I want to remove this, how am I going to remove this? By dividing with y here. So if I factorize out y squared, divide now by y squared. What you factorize out is what you divide with. So when I factorize out this, I divide with the same thing here. This divide it here, you get 1 plus. When you get this and you divide it here, we have e y over y. So when you multiply back, we get this, and multiply back, this one will also be having that. Now we say that the whole of this approximates a 0. And we say that our ey over y will approximate 0. So if that is the case, now is that our error in x over y will be equal to yex minus x ey the whole over y squared. So what happens there? We introduce our modulus sign. If I introduce now e of x, y, it will be now modulus both sides. This will be the same as y, ex plus negative x, ey, the whole over y squared. But no properties of modulus. We say if you have modulus of a over b, this will be modulus of a over modulus of b. So now we are free to separate this. Now, it's going to look at this step. I'm not doing anything. So I'm just separating the modulus. This is the same as y ex plus negative x ey, then over modulus of y squared. So from there, I'm introducing the less or equal to, this would be less or equal to. Now if I separate these two, y e x plus negative x e y, now all over y squared. That. Now we divide this here and also divide this there. As we are going to see what will happen after that. We be careful, don't rush. Why are we having this? Because this is going to be less or equal to this. Now, from there, you can start now. My error, e x over y, will be less or equal to. Now, if I divide this here, because this is the same as y ex over, then plus modulus of this and negative, it will be now positive x ex, the whole over modulus of y squared. When we get this, it will be the same as y ex over y squared, then plus what is going to happen here. I'm going to be adding modulus of x ex over y squared. Now what happens? The whole of this is less or equal to. Now you see that this one is going to cancel. I'm going to be adding e x over y. This one is cancelling with that. Then here, now you see that here, this one I can separate it as plus. This one you see that I can get this as modulus x over y into modulus of ex over y. When I multiply this and this, I get back to the same thing. Now, if I factorize out the whole of that thing, if I factorize out this here, when I factorize out x over y, I'll be having now, because this is not here, I'll be having ex over y times now the reciprocal of this, which is y over x, now plus ex over y. This is in modulus, and this is also it's in modulus, and so this and this will cancel. So which will be less or equal to modulus of x over y into modulus of ex over x, this one, plus modulus of ex. Sorry? Did I change things? This one is ey, please. This is ey. Sorry for that. Yeah, but that one is ey. So this is ey there. So I hope you can follow. This is ey, modulus. And so if you want now, E max, now E of x over y. If you want the maximum, that's going to be equal to x over y, in brackets, E x of x plus E y of y, then we close our brackets there. So this is going to be our orange whenever you have quotient. So from there, absolute error will be equal to the same thing, x over y then plus ey over y. And if you come to relative error, the same will be given by absolute divided by this. So it shall be added now. Remember, this one is the same as x over y. Divide into ex over x plus ey over y. The whole of this we are dividing consider this, we will cancel with that. And so our relative error will simply be equaling to ex over x absolute, then plus y over y. Okay, so if you want now our percentage error, it will be just, now we just get this times ex over x modulus plus ay over y modulus, then times 100. That will be the case. So that's it, members. That's how we had to get this. Sorry for taking this as dx, but I think we finally sorted the case. Here, what we did is, when you factorize out something, you divide or you multiply with its reciprocal. So when you divide, what you factorize out, you divide. So remember, we said that r modulus of x over y is the same as x over y if all of them are positive. Now, that's what, when I factorize now, I'm seeing this, when I factorize it out, it means that this same thing, it's reciprocal. I multiply it here and I multiply it here. When I multiply y over x here, that's why we have a 1. When I multiply with the reciprocal y over x here, this will cancel with this, and I'll be remaining with that x there. So, that's a simple explanation there, and that's it, members. Now, we are going to see now proofs about propagation of errors. Those proofs about propagation of errors in our next lesson. So, see you there.